Well, statistics is really about deriving information from data, deriving knowledge or structure from data, okay? A statistic is a number, right? It's a numerical value that encapsulates some pattern or some idea about a set of data. And it's really all machine learning is, okay? It's just you can think of it as advanced methods in statistics. The reason it's called machine learning and what's really driven this field in the last 10 years beyond statistics is two things. It's the explosion of the amount of data that we can store and process. Well, we can gather and store, first of all. Okay, so everything, including the drops in prices of memory and higher random access memory in our computers to bring up these files for processing, everything like this pure technology advancements has allowed us to capture a lot more data. And on the flip side of that, the ability to process these data sets and advances in computational, the actual CPU processing cycles of computers in order to be able to process. This has allowed us to use models which are far beyond the ones that have been used in traditional statistics. The end goal is the same, okay? It's to derive some kind of knowledge from data. So this is the basic construct you see in statistics and in machine learning. But in terms of the learning, the methods and actual algorithms that we use are only possible today. Yeah, this is why this is so exciting. A lot of the ideas behind machine learning, so you hear a lot about neural networks, artificial neural networks, they were actually written in the 60s and 70s when the concept of computation was actually first coming out. Okay, so when IBM was first kind of letting people work on their workstations, people were thinking already about how they can use these new algorithmic potentials to understand data. A lot of the concepts were written, but were actually impossible to implement. And it's only in the last decade that computational power has caught up to those methods. So a lot of times you think, well, nothing's really new under the sun. Computers have been around for a while, but actually there are new possibilities becoming possible through pure computational capacity. Okay, a lot of things we're going to cover today were thought about 40 years ago, but only now are they possible to do, not just by professionals and sort of specialists, but by everyone here on the machine you brought with you today. Okay, so basically machine learning in relationship to data mining, the two things, data mining is the name of this course, right? It's where we take a lot of our inspiration, even though we cover a lot more than machine learning. And the reason I called it data mining the city instead of learning or machine learning the city is because data mining is, in general, even though people use it interchangeably, data mining is a more broad concept. And data mining you might think of as any methodology that creates structure from data, okay? It's taking the data and creating some kind of understanding. So again, it's a model like this. Machine learning is a more specialized field of study, and it basically provides the computational tools to do this data mining. So the two can be seen interchangeably, but data mining is the desire to kind of derive structure. Machine learning is that set of tools that's actually used to get the structure. Okay, so machine learning is, like I said, a separate field of study. It's been developed equally from the side of mathematics and incorporates fields like linear algebra. This is like working with algebra and matrices, probability theory, differential equations. That has all contributed to the computational side of machine learning. And from the other side, it's been equally developed in the fields of computer science, developing such techniques as algorithmic design. So the actual models that are used to derive these structures have a lot to do with algorithmic design, database design, and database access, and optimization algorithms. Okay, so this field right now is a specialization in both mathematics and computer science. And based on what I just said, you can imagine that it's a very complex field to truly understand. It's at the level of those fields. Those are kind of the prerequisites for working. If you're going to develop your own machine learning algorithms, that's what you would need to study, right? But that's not what we're going to do in our class. What we have here, like I said, is an application-based approach. So this lecture will give you all the foundational principles, enough so you can use the tools intelligently. Okay, we're not going to be revolutionizing new approaches to machine learning. We're just going to learn enough to be able to use those tools competently. Okay, this is what we really should care about. This is what a statistics class for urban planners should be about. Okay, we're not going to become statisticians. I think most of us don't want to. We just want to make sure we can use those tools in a way that we can validate the results. We can understand the results and we can competently show them to other people, okay?